This simulation provides some insight into the motion of the Earth around the Sun and of the Moon around the Earth in combination, going around the Sun, and also man-made satellites. And so to start, I'm going to pick this, which is the just simply the Earth going around the Sun. So let's go ahead and start that. You can see the Earth is rotating and executing an orbit around the Sun. And so if I turn gravity force on, there's an equal and opposite force. Um, so this blue arrow pointing from the Earth towards the Sun is the force of the Sun on the Earth, and this blue arrow pointing equal and opposite to the first one from the Sun to the Earth is the force of the Earth on the Sun. They are equal and opposite to each other, despite the fact that there is many orders of magnitude difference in mass between the Earth and the Sun. Now let's put velocity in, and you will see that the Earth's velocity is perpendicular to the force of the Sun acting on it. So the effect of the force on the Earth isn't to increase the speed of the Earth, at least not to a very good approximation, to the approximation that the orbit is circular. It's simply to change the direction of the velocity vector. So lastly, let me click the path, and now it's tracing out, the Earth is tracing out a path. It looks like a circle. It very nearly is a circle. In a more accurate representation, it's actually an ellipse. Okay, so let's go now to the Earth, Moon, Sun system. And here's the Moon, here's the Earth, and here's the Sun. So let me go ahead and start it. Turn gravity force on. If you look carefully, well, you can see the two big blue vectors, but you can also see that there's a vector, force vector between the Earth and the Moon, showing the force of the Earth on the Moon and of the Moon on the Earth, again equal and opposite to each other. Here's the velocity vectors. So the Moon's velocity vector is continuously changing, and if we put path in on that, you get some mathematically beautiful orbits, orbiting trajectories. So do you think the purple orbit of the Moon is going to lace nicely into where it started? You will shortly see whether that's true or not. Let me put the point right there and see if it knits up with itself. No, it misses by a little bit. So let's stop and then go to just the Moon and the Earth. So here we see the Moon circling the Earth, and so the Moon is doing the same thing relative to the Earth as the Earth does relative to the Sun. There's gravity, again equal and opposite to each other. If you look carefully at the Earth, you can see it is wobbling. Velocity vectors, there's a tiny little velocity vector on the Earth. Velocity vector on the Moon is perpendicular to the force vector. And here's the path. Okay, this is a man-made satellite. So there it goes. Force of gravity, velocity, path. It's quite similar to the orbit of the qualitatively of the Earth about the Sun. The difference in mass between the satellite and the Earth is huge. This is on the order of 10 to the 3, 10 to the 4 kilograms, and this is on the order, the Earth is on the order of 10 to the 24 kilograms. So it's roughly 20 orders of magnitude difference. So the Earth essentially doesn't wiggle at all. Okay, so we can also go over here and see the scale, more realistic scaled models for each one of these. And this is what the satellite looks like. This is what the Sun-Earth system looks like. This is what the Sun-Earth-Moon system looks like. This is what the Earth-Moon system looks like. And this is somewhat representative of a typical satellite orbit.